Good afternoon, YouTube. It is January the 2nd. Currently, it's about 3 in the afternoon. Real quick, wanted to show you one of my maintenance schedules. Today, I happen to be going in and doing my monthly watering and maintaining of the batteries, and I thought I'd bring you along. As you guys can see here, minimum state of charge at the beginning of the day was 55%. For the last 4 or 5 days, we've roughly had about 18 hours of just drizzle and rain. Most of that during the charging times of the day. Today was no exception. We just basically caught us a sun patch for a brief moment. Currently, I'm running my generator outside. It's a Ryobi 2200 inverter-based generator. It works very well with the inverter that I have. So I use that to usually top up my batteries or balance them. But today I'm using it to charge it first so that I can go ahead and get the water level where it needs to be before I start to fill it. Currently been charging for about 3 hours. That generator will run 5 hours on 1 gallon. So hopefully in the next hour or two, I should be at 100%. Real quick, I wanted to show you some of the other things that I do when I first start with the batteries. I've already used my multimeter and meter mode just to basically be able to see how much amps I have going into each individual battery bank. Currently, I'm drawing in about 60 amps, fluctuating between 60 amps and 50 amps. So roughly, I estimate that each battery bank should begin so around 10-15. And then I'll basically kind of let you guys see what I do to do that. I usually get somewhere in between, so I'm bringing in about 20 amps on that particular load level here. And usually I'll just go to each battery pack and just see what we got coming in, what we got going out. And this right here is just a configuration of positive and negatives. They hook up into a bus bar, so these are kind of inaccurate. I always try to use the middle of the battery bank to kind of let me know what the load is actually coming in or going out of the battery. And like you guys just saw, it's about 20. So I've tested the other two levels and they were also at 20. One interesting thing that I noticed today while I was maintaining my batteries, I'm just kind of curious. It was getting kind of warm in here. It's the winter months, so I'm not seeing uh, the sun being a big heat contributor for us in the home. Recently, I've just kind of started monitoring things. I'm going into school to be a energy auditor and kind of do some things that'll help me with making sales of some solar design systems and just be more educated for myself. And anyway, I bought the equipment, and one of the things that I noticed today, you guys will hopefully be able to pick this up on the monitors. I have the back wire there. It's a little warmer than the others. In fact, it's a lot warmer. That one's running right at 123.2 in Fahrenheit. And this one right here is run 20, I think that's the same wire. So I got a bad connection on that wire there. But basically it's 129. And if you look for perspective, this wire here is now showing in there. And if you can see, I have to use the laser. The laser dot showing on there, okay? And we have 83.3. So definitely that back lead wire has a kink in it, has a short in it. Might even just be a bad wire. And the weird thing about it, all these wires were made at the same time. These wires right here in the back, I think through transfer of that power, going through the kink is a little warmer than the rest of them as well. This one's at 99 degrees. You get a little closer to the back here. I replaced this wire because it was actually at 104. But notice as soon as I replaced it with a better wire, it's right down to 84 degrees. So one of the projects that I plan on doing when I equalize the batteries today is to basically go ahead and get those cables wired up a little different. Most likely I'm just going to end up replacing the ends on the wire so that I can have better setup. Now, one of the wires that I did end up replacing was this one here. You guys can probably see it. I don't know. Well, there we go. Gotta get used to the camera. Okay, so this right here doesn't seem like a bad wire, but it is. Only because it is one out or one out gauge wire. It's the proper gauge, but because of this bigger gap in here, it has a little less surface area actually touching the terminals. When I replaced that wire, I ended up getting a much cooler wire when I'm transferring upwards to 20 amps. And just to kind of give you guys an image of what it looks like, this right here clamps onto there. Okay, if you can see, look how much extra surface area we have. I could use a washer to pin that down, but instead I ended up I already had the wires or the right pieces in the shed. I went out and just replaced the wire that's in the back there. I also replaced another wire on one of my other levels. But you know, with using that thermal scope, I was able to kind of isolate where I was having a kink inside of my charging system. It might not seem like a lot. It still works. It does a lot of high output. But when you're seriously charging this thing at 60 and 80 amps, 48 volts, it tends to bottleneck where it's the weakest, and that bottleneck could end up costing you a big loss in power. But not only that, if it gets hot enough, it could also start to melt some things. And the last thing you want in a battery system is a fire when you have it charging. So with that kept in mind, I'm gonna go ahead and do some more equalizing of the batteries, and hopefully be able to mix these videos up for you and let you guys see what we've done today. Okay, YouTube, I'm back again. Hopefully you can hear me pretty well. If not, I'm sorry. I wanted to let you guys see me outside working on my batteries, cables. I do have a spool of 1/8 gauge wire that I use for my battery bank interconnects. And what I was trying to show you inside that I wasn't able to do out is the difference between the types of cable, terminal connectors. You can see here a little bit better where this crump bell type connector is much wider than the birth of that one. That difference is what really causes a bottleneck with the batteries actually charging, and that causes a big issue. So today I'm going to be making new wires. I have a crimper, got my wire cutters here, got all my supplies out. I'll be working on that today. I also hopefully can do an update on my PIP. 240 watt or 240 volt system that I have running for my AC system that's running inside the house. Anyway, let me go ahead and get to the wires, and you'll see a little bit more as I keep going along maintaining my batteries today. Hello again. Wanted to real quick, while my batteries are now charging and my cables are replaced, to show you guys one of the other additions I've done, and I recommend that you guys do something similar for just training purposes. My whole home understands how my system works. My whole home understands the disconnects and where faults can be when I'm at work, or if I'm not home and they're here. They understand where fire extinguishers are. They understand where the disconnects are. So one of the other things while I was designing that system I did was basically make a file here of my array, basically to where I can print it, put a label out, or keep a book of all of my setups and how they integrate. And it's a living file. I try to keep it up to date based off of any updates that I do. But this really helps me when it comes down to giving tours or showing people how my system works. They can kind of walk away with an understanding of basically what it takes to make this thing work. And then on top of that, if someone like a firefighter or an electrician were to come by and want to qualify my system, they could follow along, and this pretty much follows that diagram. It might not go to any very specific specifications like on whatever the companies do, or I don't even know if there's a standard for this, but I did want to take the time to basically let you guys see what I've done. And if you've seen some better ones, or if you know of the right connections or the right type of diagram, let me know. Let me stop the music. I'm sorry about that. Hey. All right, so pull PowerPoint. I actually used PowerPoint for this. It made it real simple. Ignore the kids in the background. I just had them made some lunch for them, so they're in there eating and they're noisy. Jeez, you guys pretty much have families or been kids before, so you understand. Well, anyway, I have them labeled. This is my tilted array. This is my large array. It actually shows what my rated voltage is, what my rated wattage. It even tells the degree and the angle that I have it tilted towards the sun, and I got an emergency disconnect sticker on there. My intent is to get these printed up at Walgreens and place them inside of my board so that I don't have any issues. This is another array. This is actually the pergola. I have 6 panels total on that one, and you can see here how they're positive, negative, positive, negative. Anyway, they're hooked up in 2 series, 3 parallel configuration. That gives me 1800 watts on that particular setup, and it tells you the degrees that I have it facing and the set angle that I have it put at. If I ever made systems, I would definitely do this for every system I would generate, so that if I ever had an issue, for instance, address A calls me and tells me, hey, something's going on, or I'm looking at the optics already and find that there's an issue, I can pull up the diagram before I get out there and know exactly how that setup is supposed to look. Or even better, if someone has to add more additional panels, I would know what configuration that I could set up, and actually what size panels to order. For instance, if I needed to go with 60 volt cell, 60 cell panels, 72 cell panels, or if I can actually just parallel those up if the VMP is pretty close. So anyway, you can see here on my left array, I have 2 front arrays. Those are my newer arrays that I showed you guys. I just didn't want to waste those panels, so they're a little mixed matched. I have 100 watt panels to the left and 85 watts panels to the right, but as you can see, the VMP is pretty close. The VLC is closer, but the VMP, for what they're doing, actually is real close, and I get the best of both worlds. I get maximum amount of power from the 85 watts, and real close with those 100 watt panels. The real thing when you consider putting mixed panels into parallel with each other is making sure that VMP is the same. Your amps will add up. So to the left, I'll have 5.29 at optimal and 4.65 coming from the right at optimal, and that'll give me a good amount of power, at least around 600, 500 watts coming in addition to whatever else it's hooked up to. Going on down the list, I've made this all one file so that you can basically follow the diagram. I have array 1, array 2, array 3A, 3, and 3B, which basically follows that same line here. Let me go back here. It's even labeled 1, 2, 3A, and 3B. So you guys can kind of follow that, and it shows the junction boxes combined. It shows my 40 amp fuses basically joining right before the outback charge controllers. As I change or add to it, if I want to add a wind turbine, I just continue that file a little bit further down and have no issues there. This one goes out to a 63 amp. The VLC on this was much higher, so it's cranking that voltage down. That's why I only have a 40 amp on that. It's rated for the amount of power going through. On the 63 amp side, that one's actually cranked up because of how much power can be dialed up out of that higher VOC. With my MPPT charge controller. So going over it, goes into the battery bank, and basically I just showed that it's 6 volt cells, and even have right here my configuration 675 amp hour battery bank, and it's comprised of 24 225 amp GC2 batteries in the 8 series 3 parallel configuration. I have a 30 amp fuse to inverter and a 48 volt BLS desulfator hooked up to the junction. I have 3 battery balancers for every 12 volts. I have those batteries balanced to each other. And then you continue this down, and it gives you the AC side of things. From my battery bank, it shows 60 amp fuse DC going to my Outback GTFX 3048 inverter, coming out of a 30 amp fuse. My system rated at 35 amps, but I let it, I underrated a little bit just for thermal. As soon as it hits 35 amps, that 30 amp basically keep running for several seconds, and then it'll trip. for the most part, that's a safe bet. I've read from, I can't believe if it was R. Hansen or if it was, I believe it was R. Hansen or maybe it was a solar electricity and gears or whatever. But one of those guys had a video on the fusing, so I actually rated that down to 30 amps instead of the 40 I had on there, so that I could make sure that I didn't damage my inverter. Then right here, that's basically meant to look like a big battery. Until I find something better, I can make a house or something there. But anyway, household loads are at 120 volts VAC, 3000 watt regular use, at 4500 surge, 35 amp grid max if it's coming in from the grid or going out. I have a 48 volt, well, same battery configuration that was on the previous page. Anyway, I wanted to add this to my video because it's a critical part of what changes and updates I've done in the past couple of weeks. I'm going to continue to let my batteries charge up. It's getting kind of late. I might not actually be able to water my batteries until this evening, but I am going to continue to give you guys what I've changed in between now and then. Thank you. Okay, family, I'm sorry. Unfortunately, it's gotten a little too late today to be able to show a lot. As you can see, it's overcast. Normally about 3 p.m. the sun starts casting shadows on these panels, and the way I got them configured, the top panels are basically going to be getting powered, and the pergola will be getting powered. The front two sets are going to be getting powered, but I'm getting so little power coming in that it's probably going to take closer to 2 hours from now before the batteries are at 100%. Typically, I could say that everything we do on off-grid is pretty simple and straightforward, but you know, I never could underestimate some of the things and mistakes I've made. So I'll come outside and kind of let you see some of the changes I've done. Hopefully you guys will be able to look at some of the purchases I've made and see how they can assist you in watering your batteries. The main thing is you don't want to have your water level go above your battery plates. You never want your battery level, you don't want it to go above the little bubble outline. You never want it to go below the battery plates. Both of those will cause some issues. One, if it's too filled with water after it's charged, the next time that your battery's charged, it'll be off gassing and it'll risk a lot of electrolyte being bubbled out of your battery. If you do have it, the water level go below the plates, it can cause stratification at the top of the plates, and that's an irreparable damage, basically, where it oxidizes to where you will not be able to recover however much of that cell was basically exposed to air. Very sensitive. The batteries are very sensitive. They're pretty rugged as far as being able to take an overcharge compared to AGMs, but when it comes down to watering and making sure that you maintain them, they can be very sensitive to what you do or not do to the battery. So just take very good care of them. I do have another project going off in the works to control the 230 volt side or 240 volt side of my house. I've come across a page where one of the guys that I've been watching is taking laptop batteries and taking them all apart and built some cells. And what I did is the same thing. I did an experiment, built a 24 volt battery just to see what it would do. Put it inside of one of my kids' little cars. It drove around the house about 20 times at double the speed that it normally does. The problem I saw with it, in that small of a battery pack, the wires are kind of thin. The batteries actually got warm versus the wire, and that kind of concerned me. It got up to 140 degrees on my thermoscope. So I'm waiting to get more cells. I'm gonna double up that and triple it up until I get comfortable with the temperature that it maintains. I'm understanding that it's kind of it's pretty normal for the batteries to get warm during power draw, but I do not feel comfortable putting that in a load configuration where I'm depending on it, and the draw could be intermittent, 40 and 50 amps like it was on this, and depending on that to keep heat in the house. I didn't feel safe with that. So I'm gonna wait until my stockpile of batteries builds up. You guys can help me on that. I got another channel going for that. But that's the off-grid update today. Unfortunately, like I said, I couldn't show you the actual watering process, but next time maybe we will be able to get that over to you. Thank you for watching. As I always say, I appreciate you guys for everything that you do. Appreciate the fans, the friends, the subscribers, and the commenters. So if you could hit the like page or the like button for me. If you would like to, please subscribe to the page, share. But most of all, have a great day. Happy New Year.